After graphing all four equations, you should have been able to find the x and y intercepts and written them as ordered pairs. If we focus specifically on the y-intercepts, you'll notice that there's something common in all four of these points. And it's actually something that's common in all y-intercepts. In order for something to be a y-intercept, it has to fall on the y-axis. At that location, our x-coordinate is always 0. So anytime we have a y-intercept, we know that the x-coordinate will always be 0. Which means it'll always be in the format of 0, comma, whatever the constant is in the equation. When we talk about an x-intercept, we'll notice the same kind of things going on here. The difference is that instead of the line having to cross the y-axis, it crosses the x-axis, which means at that location our y value has to be 0. So it's almost the same statement, but in this case, for an x-intercept, our y-coordinate will have to be 0. Which means that it will always be in the format of x comma 0, whatever x is. Now the reason why this happens is actually because we're dealing with solutions to equations. So if we're looking at an equation here, y equals negative 2x plus 4. Well, for an x-intercept, what did we just say? We know the y value has to be 0. So we plug that in, and we solve for x. In order to do that, we subtract 4 from both sides, leaving us with negative 4 is equal to negative 2x. Divide both sides by negative 2, we get that 2 is equal to x. Thus we have the point 2, 0. And this was for the first equation. For the y-intercept, well, it just means plug 0 in for x. When we go ahead and simplify this, we notice that we have 0 plus 4, a simple application of the identity property of addition, and we know that y equals 4, giving us the point 0, comma 4. Take a moment now and use algebra in order to find the intercepts for the remaining 3 equations here.